Picture a celestial orchestra composed of countless stars, planets, and moons, all moving in perfect harmony. Yet there's one part of this cosmic masterpiece that has puzzled astronomers for ages: exoplanets. These are planetary bodies that exist beyond our solar system, hidden in the vast reaches of the Milky Way. What might surprise you is that, among the seemingly infinite number of these celestial forms, there lies a world strikingly similar to Earth, so much so that it's been called our planet's cosmic mirror. We enter this fascinating realm through observations made possible by a powerful tool, the James Webb Space Telescope. One of its key targets is Proxima b, a world just 4.2 light-years from Earth. This telescope is changing the way we explore the universe. It's bringing us closer to understanding these far-off systems. Now imagine your awareness stretching across the enormous span of our galaxy, the Milky Way, home to over 1 trillion exoplanets. To grasp this enormous number, consider that if each planet were the size of a sand grain, they would not only fill the Grand Canyon, but would also form another such canyon, stretching for miles. Even more remarkable is that around 20% of these worlds may be Earth-like, based on similar geology and atmospheric conditions. That means there's roughly a 1 in 5 chance of finding a true Earth twin, and the possibilities don't end with the planets. Many may be accompanied by a staggering number of moons, potentially up to a quintillion, engaged in graceful gravitational motion with their host planets. This opens up vast opportunities to find environments that could host, or even already support life. As we peel back the layers of this cosmic expanse, one instrument stands at the center of our investigation: the James Webb Space Telescope. Equipped with technology far beyond traditional telescopes, surpasses previous instruments with exceptional clarity and range. Its primary mirror, measuring 6.5 meters across, is nearly 3 times larger than that of the Hubble Space Telescope. This enormous size allows it to detect faint starlight from billions of light-years away and analyze the intricate details of orbiting worlds. What sets this telescope apart is not just its observational strength, but its advanced equipment: infrared detectors and spectrographs that do more than just view. These tools examine and separate the unique light fingerprints emitted or reflected by distant celestial objects. With this capability, scientists can determine the atmospheric makeup, chemical composition, density, and even mass of these distant planets. It's a space-based forensic lab capable of identifying signs of water, organic compounds, and possibly oxygen clues, pointing to the potential for life. This instrument represents more than just a successor to earlier space telescopes. It marks a major leap in our capacity to understand the universe. While past missions amazed us, the findings now possible promise to be even more groundbreaking. One of the most intriguing of these distant worlds is Proxima b, discovered in 2016. This exoplanet has captivated scientists with its puzzling mix of familiarity and mystery, not unlike a character from classic literature. Why the interest? For starters, it's located in our galactic neighborhood, only 4.2 light-years from us. To put that into perspective, if you could travel at light speed, the trip would take just over 4 years, about the time it takes for a political term to end or for a TV series to wear out its appeal. This proximity is monumental. The universe spans about 93 billion light-years, so finding a potentially habitable planet so close is like spotting a gem in a mountain-sized pile of rocks. A gem that might hold answers to some of the biggest questions about life beyond our world. Proxima b is essential in this search, not just because it's nearby, but because it offers the thrilling possibility of being Earth-like, perhaps even a second Earth. It orbits within the habitable zone of its star, a region where conditions are just right for liquid water to exist, not too cold. Imagine rivers flowing, lakes glimmering, and oceans as deep and mysterious as the ones on Earth. But before we imagine vacations on Proxima b, consider some of its unusual features. A single day there lasts about 11 Earth days. Think of sunrises. That unfolds slowly, casting long golden hours and sunsets that stretch into the extended twilight. Beautiful. Yes. But this also raises questions about climate and how human biology would cope. Would we eat more often? Would our sleep cycles shift dramatically? The rhythms of life might seem both oddly familiar and strangely foreign. It's as though nature has handed us a riddle, wrapped in layers of wonder and challenge, urging us to redefine what it means for a world to be livable. But how do we gain reliable information about a planet we've never visited? That's where the James Webb Space Telescope comes into play, folding its full suite of tools like a cosmic multi-tool. This is no ordinary telescope. It's a high-tech observatory floating in space, capable of using sophisticated instruments to study distant planets with a precision unmatched even by the most advanced labs on Earth. Through the use of spectrographs, analyzes the light these worlds reflect and emit. Each substance in a planet's atmosphere leaves a specific mark in the light spectrum, allowing scientists to decode the planet's composition, pressure, and even whether it harbors molecules tied to life such as water, carbon, or oxygen. This is not just observation. It's investigative science on a galactic scale. With this capability, we're not passively waiting for discoveries. We're actively pursuing them, parsing the atomic clues hidden in distant starlight. The telescope is much more than a viewing device. It's a space lab, a detective, and an analyzer combined. It allows us to turn our theories about other worlds into testable ideas. And every test brings us closer to understanding what lies beyond Earth. Just when we thought the story couldn't grow more astonishing, a new twist emerged, like something from speculative fiction. Astronomers studying Proxima B detected signal unlike any other, was so structured and distinct that it stirred excitement across the scientific and public spheres. It was called a possible technosignature, an electromagnetic signal so detailed it hinted at intelligent origin. For a brief moment, the world held its breath. Could this be the proof we've been waiting for, that we are not alone? But just as quickly as it was detected, the signal vanished. No repeat, no trace, only silence and a flood of speculation. Was it a natural occurrence, a fleeting alignment, or something deliberate? A message? A sign of intelligence? The mystery persists, sparking intense debate. Was this a one-time phenomenon, or a part of something greater we've yet to understand? The questions multiply, but the journey continues. The story of cosmic discovery is still being written now. A new chapter is unfolding, led by researchers, pushing the boundaries of how we look for life. Instead of only analyzing strange signals, they're using the telescope to look for artificial light on distant planets, both on their day and night sides. This idea carries astonishing implications. Imagine finding what appears to be a glowing alien city, its lights shining into space like a cosmic beacon. As we continue this exploration, the James Webb Space Telescope proves to be a game-changer in how we observe the universe. It doesn't just look, it deciphers, dissects, and transforms data into insight. It's a key instrument in piecing together our place in the cosmos. We now stand on the verge of answering questions that have stirred human curiosity for centuries. Are we alone, or are there others out there navigating the stars? Proxima B, with its resemblance to Earth, gives us a compelling view into what another habitable world might look like. Its potential to host life is both exciting and deeply significant. Yet as we look further into the unknown, we're reminded that this search comes with challenges. Many factors affect a planet's ability to sustain life's distance from its star, its surface conditions, its atmosphere, and its access to water, and that unusual signal. It's opened an entirely new line of questioning. Was it truly a hint of intelligent life, or just cosmic noise? The debate is ongoing, but one thing is certain. We've barely begun to understand what lies beyond our world. The James Webb Space Telescope will be a crucial part of that effort in the years to come. As it continues to deliver data that could reshape our understanding of space, we're reminded that this is a journey, not a race. Each discovery adds to a growing picture of our universe, and with every leap in technology, we move closer to unlocking new levels of understanding. This quest isn't just about spotting planets like ours. It's about grasping the deeper rules of life itself. Are those principles universal, or are they unique to Earth? Are we the only ones asking these questions? Or are others already out there, having answered them long ago? The impact of such discoveries could redefine our future and our role in the cosmos. As we continue to explore, one truth stands firm: we've only just begun. Each new finding takes us a step closer to solving the great puzzle of existence. And maybe, just maybe, we'll discover that we're not as alone as we once believed. The universe is alive with movement and change, and there's still so much to learn. Every bit of information we gather brings us closer to understanding this vast and ancient expanse. And this pursuit isn't reserved for scientists, it belongs to all of us. What we uncover could shift how we see ourselves, our planet, and our future.